Hi, in this video we will be talking about how to calculate n choose r efficiently. So you need to calculate n choose r given the values of n and r, okay, and you are given the values of n to be less than equal to 10 to the power say 5, and r is also less than equal to 10 to the power 5. Now as you can see that if n is 10 to the power 5 and even r is some small value like 10, this will not fit in LLI. So we definitely need to find this value modulo some mod. So let's suppose we need to find this value modulo 10 to the power 9 plus 7. Okay. So how do we calculate this n choose r mod? Let's call this value p. Okay, some prime p. Okay. How do we calculate this? So since these values are large, we cannot directly go ahead and multiply things up because that will start overflowing. So we need to be using the modular arithmetic to calculate this value. Let's first look at the definition of this. Okay. So what is n choose r? We know that n choose r is actually equal to n factorial by n minus r factorial times r factorial, right? Now if we can somehow calculate this, let's suppose a, this as b, and this as c, okay, this is r factorial. If we can calculate these three numbers, it's just a by b times c. So what you can do is that you can multiply b and c and take proper modulo and like make it invert. So this is nothing but a times b inverse multiplied by c inverse. Okay, so if you first of all calculate the inverses of these two numbers modulo this p is 10 to the power 9 plus 7. If you first calculate the inverses using binary exponentiation technique that we discussed, and then if you find out the multiplication of these three numbers, you will get the values of n choose r, right? Now we need to calculate these three numbers. So once we have the value of a, b and c, calculating this is pretty easy and straightforward. You just need to do a binary exponentiation inverse technique. Now how do we get these values? So it eventually boils down to calculating n factorial efficiently, right? So how do we calculate n factorial? So we don't really need n factorial, right? We just need n factorial mod p. N factorial itself becomes pretty large after values like 20 and all. So you just need the value of n factorial mod p, right? So how do we calculate n factorial mod p first? Now to do this, you can just loop from 1 to n, since n is up to 10 to the power 5 itself. Whatever the range of n is, n minus r will also be in that range. If r is greater than n or less than 0, it is 0 by default. Like you can handle that case separately. If it is in this range, even looping in these and these would not be difficult. So you can loop from, let's say, 1 to n, keep on multiplying the numbers and keep taking proper modulo, and then you get the value of n mod n factorial modulo p. And if you do 3 times, you will get the values of a, b and c depending upon the values of n and r. And once you have that, you can use exponentiation. So to calculate this, you will need order n, right? So calculating a takes order n. Same goes for b and c, like b and c as well take order n. And then calculating these two inverses take order log of n, sorry, log of p, right, to get b inverse and c inverse, and then multiplying them takes order 1. Okay, so there is this order n limiting factor, right? Now suppose you had to find out the values of n choose r repeatedly fast. So what I mean to say repeatedly, so suppose you need to calculate the values of n choose r, okay, and you are given that you will be given 10 to the power 5 different values of n comma r, and each of the n is less than equal to 10 to the power 5, and each of the r is less than equal to 10 to the power 5. So there will be 10 to the power 5 test cases, okay, and for each test case you need to find the values of n choose r. So now for each test case you need to work in better than order n, because if you use order n algorithm, so in each test case you will get order 10 to the power 5, and if there are 10 to the power 5 test cases, you will get 10 to the power 10, and that won't fit in time limit, right? So you need to do better than order n. Okay, so there are 10 to the power 5 test cases, and in each test case you need to find the value of n chooser. So how do you do that in that case? So what we can do is that the limiting idea in our code is this part, right? Calculating this a, b, c takes order n. So for all these test cases, we just need factorials, right? There will be a lot of factorials, but all of the factorials would be repetitive, right? There are only 10 to the power 5 distinct factorial types that can come. Like either you will ask 0 factorial, 1 factorial, 2 factorial, and 10 to the power 5 factorial, right? These are the only factors that you will need across all the test cases. So what we can do is that rather than calculating the factorials using loops, what we can do is that we can simply use a caching idea, that we save the values of factorial in an array. Okay, so we create a factorial array which is equal to, so factorial of I is equal to I factorial. How do we create that? We just simply use this. Factorial of 0 is equal to 1, and factorial of I is equal to I times factorial of I minus 1. We use this relation for I greater than equal to 1 up to n. So we calculate all the factorials from 1 to n. So 0 is there by default, and from 1 to n you can calculate it using this recurrence. So you just loop from 1 to n, keep on calculating all the factorials. This would be I minus 1. Right? And after this, once you have calculated this factorial, now if you have to calculate some n chooser, you will need these values of a, b, c, right? But now you can quickly look up into the array that you have created using this, and you can get the values of a, b, c in order 1, right? Now this part becomes order 1, this part becomes order 1, and this part remains order log n, right? Log p. So now the limiting is this. So for each test case you need order log p, right? So for each test case it will take you, like per test case, for each test case you need order log of p, because everything rest is order 1. So this is the dominating part. So total time taken complexity would be order number of test cases times log p, and you can see that this is 10 to the power 5 and this is 10 to the power 9. So even if you put in the values, this fits in the notion of 10 to is less than or equal to 10 to the power 8, and that will pass. Okay, so in case you need to find a lot of factorials repeatedly, you should be familiar with this idea of caching, where you save the factorials that you will need in the calculating n chooser, and then you can even calculate n chooser really fast if you have to calculate it a lot of times. But if you have to calculate just one n chooser, you can even loop by using this order n loop over here to calculate factorial. Okay, so that's all about n chooser. One extra point that I would like to mention in this video is a common bug that people make. So what is -2 mod 3? This is nothing but 1, right? Because we know that negative numbers don't matter and we need to make it positive, and we add 3 so that it becomes 1, right? 1 mod 3. So what is -2 mod 3? This mod is when you do it in computer or in program. So let's say you are using C++. If you do this, what is the result that you will get? Like if you print out, if you see out this, print out this using any command, what do you get? But what happens is that in C++, this reports -2. Okay, so if your answer is at some time getting negative, you need to make sure that you make it positive. So if at the end you have an answer that is negative, that might become negative, you are not really sure, what you can do is that you can add mod, take another mod, okay, and that will make sure that things are positive, right? If you have not maintained answer even in a mod form, what you can do is that you do an answer, you can do a answer modulo mod first, answer modulo mod first, like answer mod equal to mod, like you take mod with the answer and then you add mod, and then, so why is this working? If you think about this, why is this working? So if this is negative, once you take mod, it will lie between negative mod minus 1 to 0, right? Like if it is negative or 0, something like that. So if you even if you add mod, it will lie in range. So let's say even if answer lies from infinity to minus infinity to infinity, okay, minus infinity to infinity. So if you take a mod, it will lie from minus mod minus 1 to positive mod minus 1. This is the only possible range that it can like reside in, the value can reside in, okay. Now if you add mod to this, so if you add mod to this, to both the sides, this will become plus 1 and this will become 2 times mod minus 1, right? And if you then take a mod, finally the final mod, so something from here can become 0, so we write 0 to mod minus 1, right? Any value can be there. So you finally reduce things to 0 to mod minus 1. So make sure if you are not sure that you have a negative number in your answer or not, make sure you finally do this kind of operation, like you add, take a mod, make sure that you are in negative, even if you are negative, you are in the range minus mod minus 1 to mod minus 1, then you add a mod, so your negative becomes positive, and then you again take a mod, so that will make sure it is positive, okay. So this is what you should be careful of. And this is, and the idea of n chooser I hope is clear. That's all for this video. Thank you.